Well, hello, everyone, and thank you for joining me. I'm Jill Bloom, Group Publisher of Building Enclosure, and we are here today to talk about some most common questions that we get involving the building enclosure. And I am honored to be here with some enclosure experts in the industry. First, we have Will Babington, who is principal of the Facade Design Director for Studio NYL's Skins Group. And Matthew Farmer is principal for Weiss Janney Elsner Associates. So Will and Matthew, thank you so much for joining me.
Appreciate the opportunity.
Yeah, thank you for having us.
Most definitely. Well, Matthew, let's start with you. Can you tell everybody a little bit about yourself that makes you an expert?
Well, I've been in practice for about 36 years, and I have to say that probably about 80% of that time is spent working on building enclosures and facades. My background is in structural engineering, but shortly after starting in my career, I found that building enclosures were quite an interesting topic and actually crossed over quite nicely between structural engineering and architecture.
Mm-hmm.
So I've built my practice around that, and fortunately, I've worked for a company that has a lot of peers who are also involved in this field, and it's been a terrific experience ever since.
Oh, that's awesome. And Will, can you tell everybody a little bit about you as well?
Yeah. So I've been in the industry for a long time. Let's say I've been drafting since high school. I was a structural engineer first, and went back to school to become an architect, and that merged into the enclosure industry, where I've been quite active in design, writing, presenting, as well as quite a few code and other professional organizations for relative to the building enclosure.
Sounds great. Well, we were just talking before we got started. I mean, one of the most common things, of course, we see and we hear and we talk about, we write about our failures in the building enclosure. So Matthew, let's start with you. What do you see as some of the most common building failures?
Well, I think we have focused largely on water leakage. I mean, that's been the big one. And ever since we discovered that water and cellulose products don't mix, there's been a huge demand for buildings that are tighter and drier over the years. So we've focused a lot on that. It depends a little bit on the facade type, though, because we often see that when we have barrier systems such as curtain walls, precast concrete, things like that, water leakage tends to be a driver of the failures. Where in cavity wall systems or even rain screen systems, we find that a combination of differential movement is usually a factor in a lot of the failures we see. And that could lead to instability of the components, whether it's failure of connections or compression and deterioration of materials due to stress risers. That tends to put us in a place where we're dealing more with physical damage as opposed to serviceability issues.
Fabulous. And Will?
Yeah, I'm kind of relative to what Matthew was saying. The water and air leakages, those are top on the list for us. In our scope, we're more on the design side, so I have quite a few colleagues that are following down Matthew's path that give me let's go back to driver's ed and remember the blood flows red on the highway kind of videos that they try to scare you with, to really help focus and design and address those before they happen, hopefully. Because a lot of instances, even when we're through construction or development, where we'll have laboratory tests and give a dry run, or let's hope a dry run on the actual performance of the envelope. And then also field installations, where we see a lot of those failures that we hope to catch early on in the process and adjust, are in those transitions where you'd expect them. And also, going back to what Matthew was saying, with aiming for that tighter envelope, looking where we have those penetrations, where inevitably you have to make those structural connections, and making sure that those are sealed at those areas where they inevitably have to be compromised somewhat. And I think the other thing that we're seeing more and more at as we start making that transition from design to construction are what I call tolerances. It might not be a failure necessarily, but the concrete structure, for instance, has vastly different, much more loose tolerances, let's say, than what we'd have to have for the enclosure. So finding a way to marry those and be on the same page ahead of time is something that we're constantly striving for.
Yeah, and,
Well,
and I would add, oh, I'm sorry, I would
oh
just
yeah,
add
no, go
quickly,
ahead.
another area that we're seeing issues in, which kind of launches off that is actually condensation.
Mhm.
As we start developing tighter and tighter buildings, we're seeing more and more that our MEP systems need to catch up to the building tightness issues, and performance of the products that we expect to work well under certain ambient conditions may not. And that's often related to those interface conditions that Will mentioned, that you can design a window system to be very resistant to condensation. You can design a wall system, but where those two meet can be potentially problematic, and that's where the system can often break down.
Yeah, and there's no question that when you look how things have changed in the last 20, 30 years, I mean, so much progress has been made. What would you guys say have been the biggest successes? What's the one thing that you would see as a new invention or a new technology that has been put into that building envelope that has made the biggest difference?
Well, from my perspective, I think hands down, it's and it's a little bit in the weeds here, but the water resistive air barrier
Okay.
has
Yeah.
been a huge boon, because what it did, the development and standardization of air barriers and making them weather resistive or water resistive has really changed the way we think about wall systems in its totality. We never thought about air in the past, and our opportunity to seal up buildings not only helped us from an air leakage standpoint and energy standpoint, but also creates uh, almost by happenstance a tremendously good water barrier, which solves again about 80% of the litigation in construction is based on water leakage. So it's a huge boon to have a control layer in wall systems now that has double benefit in that way.
Mhm.
What do you
Yeah,
think, Will?
I would echo that a bit as well. And I think, maybe at a higher level, it's kind of the spread of this information, really. Just, we go back to I've been doing this for 30 years kind of thing, but let's evolve and be mindful about that and spreading that information around. And with us, I think recently one of the hallmarks has been two things really: the structural thermal breaks throughout, trying to make it true continuous insulation, and then I think the other item is being mindful about window wall ratios. That kind of goes to the architectural prevailing thoughts or fancies, if you will, in terms of the all glass buildings. I think we're starting to see a shift, and at least that mindfulness of, yeah, we're kind of topping out at performance, and which has a ripple effect on condensation, like Matthew was mentioning, occupant comfort, et cetera. So.
Yeah.
Yes, very good insight. Well, that kind of leads into the next question, is what makes the perfect wall? What do you think? Like, Matthew, let's start with you.
Well, it's kind of funny whenever I hear this question, I always think back to how our expectations have changed over the years. It used to be that building enclosures were about shelter. If we were safe, we were happy.
Sure.
And now we're much more in a place where comfort is super critical, and health to a larger extent. And with that in mind, I think what I feel a perfect wall system is one that's going to successfully manage water, limit airflow, maintain consistent ambient conditions, be durable with minimal maintenance. And here's a couple things that people don't think about: be simple to construct, and have generous tolerances, as Will mentioned, because the challenges are in the construction and often can be a problem in terms of, you can have a great wall assembly, but if you can't build it, it doesn't do you much good. And lastly, to be economical, we have to come up with ways to build our wall systems that drive owners and developers to wall systems that are successful, and they won't do that unless the price point's right. So I think in looking at those, I think our newer glazing technologies and rain screen systems, plus engineered cavity walls to a larger degree, do all of that and really provide a great basis for close to perfection, I guess I would say. And we're working on the cost issues with those things, trying to make them more economical, more viable, to make them more popular with contractors. And I think that feeds into, again, what Will was saying about spreading the word. If these things become standard practice, then I think everybody benefits from it. A great example of that, just as an anecdote, was we think about uh, flanged window systems. Well,
Yeah.
flanged window systems in a cavity wall construction was absolutely something that nobody ever did because it was not buildable. We always put the brick up first and then put the windows in. And now, any big city you're looking in, the windows are going in first, everything is stripped in, it's watertight, and then the brick is going in around it, which makes a huge difference. And it just took a little bit of pushing on that, on the construction industry side to make them see that that actually had a lot of economic benefit.
Very nice. Well,
Yeah, I always, when I hear the perfect wall, I think about, I think it was like 10 years ago or something, Joe Stebrick, and the Building Science Corp published that document about, all right, a one size fits all kind of, and it was, it was good, simplified on purpose, right? And get down to the basics in terms of having continuous control layers all the way around a building, keeping most of those to the outside of the structure where a lot of the bad comes from that we're trying to shield ourselves from. But really kind of like Matthew was saying there, starting with the evolution of the enclosure. Yeah, now that we've got those basics satisfied, all right, yeah, say saber-tooth tiger, yeah, we're taking care of their, take care of the moisture over our head. All right, now wind blowing through. We always want more, right? But no, it's one of those things that we're recognizing this, figuring out how to detail it more. And even though there is that one size fits all, that touchstone as you make your way through the design process, the technology's there and the mindfulness is there to start focusing on, all right, what's my climate? Of course, the codes have climate zones, et cetera, that prescriptively you should design to, but there are even some microclimates where you're looking at rain and snow and other events. And now not just historically what we have, but also anticipated, like for some of our GSA jobs, we're looking at having to look at the US National Climate Assessment to say, all right, this is what we see now, but what are we projected to see in the future potentially? Obviously, there's those specific site concerns, groundwater, topography, and context, which as we look through our building modeling, not just the whole building model to see, yeah, this facade is faced to to one direction versus another. It's going to have a different solar exposure. If we want to get things built or be more efficient, then maybe we'll tune that facade, have higher performing glass on one elevation versus another, or have more opacity versus translucency and transparency on other facades. And really those kind of feed into other areas, obviously, with the specific programs, in terms of operational energy needs, occupant comfort, which tie into that interior program. But obviously everybody's hearing that the other carbon, the embodied carbon, that we're trying to look at that finite level to see, what can be disassembled, what can be recycled, and specifying that with that anticipation. So I think that was also maybe a little bit of a look into the future, what will be the perfect wall. But in terms of, what we have now, I think it's more of we have some information and we have the ability to enact that and action it, let's say. That's kind of what I see that perfect wall being.
Well, when you think about the perfect wall, it is definitely fascinating because every time I look at a wall system, it's always fascinating to me how many pieces of the puzzle there are to make up a wall system.
More complicated every day.
Oh, yes, right. Changed a lot in the last 30 years, as we were saying.
Yeah.
But when you look at the building envelope, and there's so many codes that are out there, what would you guys say are some codes or testing that are currently in the works that everybody should know about?
Well, I think Will would agree. I think energy is the biggest driver right now in code development. We've seen a lot of movement actually to more aggressive code requirements for energy consumption, even above national and model codes in local jurisdictions. And that's driving a lot of the industry with respect to requirements for continuous insulation and other things. The challenge with that is, I think, and where I see kind of an interesting area that's going to be coming on the horizon is the adaptation of existing buildings to new energy codes, because as we already have model codes that differ between new construction and existing building construction, and right now there's sort of this weird space where we don't know whether to apply new construction energy codes to existing buildings and how successful that can be and how to measure that. So that's an area that I see is going to be uh, an area of development and influence on the industry for the foreseeable future. Personally, I'm on some ASTM committees that deal with dimension stone and masonry materials, and probably the thing that is on everybody's mind and has continued to be a subject of debate and discussion is adhered masonry systems. These are systems where we're bonding an either artificial stone product or natural stone product onto a substrate, and essentially that becomes the facade, and that becomes integrated into drainage layers and a structural layer beyond that. But the challenge with those with respect to risk over time of bonding, because essentially what we're doing is we're gluing material onto the wall, and that can be very successful if it's done properly. But the way to moderate and unify the ability to install these in a common way that everybody can understand and measure and test has been quite challenging, because there's a lot of variability both in materials and applications and geographic and climate influences that make something in Arizona behave and perform very differently than something in rural Maine. And so that's an area that's really we're very focused on in our committee work.
Very cool. Yes. Will.
Yeah, so I guess in terms of the codes, I sit on ASHRAE's 90.1 envelope subcommittee. And so what we've been having are a lot of the big pushes and concepts that we've been using and seeing for quite some time. But again, as the code is that bare minimum, that you should or you can do, not should be doing. It's something that we've seen in everyday practice, or you should see in everyday practice, stuff like air leakage, or keep taking that to the next level, quantifying it, clarifying it, even from past versions of that have been in standards. Envelope commissioning to ensure what's designed is actually making its way all the way through construction and operation. And one being a structural engineer and a envelope or architect, but an envelope consultant, that thermal bridging. I know I mentioned that a little bit before, but it's one thing where it's, again, adding greater definition to what was in the code. What is continuous insulation? And not that you can't have it to get around it. It was pretty, I don't want to say impossible. We'll probably come up with some technology in the future, but it's very, very difficult at that. So all they're trying to make you do is account for that at least. Again, we have the computational power, et cetera, to deal with that. But then you get to the level, I think, with the codes that we always hear on a lot of our meetings is, all right, we've got this figured out, more or less agree about it, across the committee. And then the building official stands up and saying, hey, I'm not an expert in this particular area. How are we going to make this translatable? How are we going to enact this?
Enforceable.
And
Yeah.
exactly,
Mhm.
exactly. So, I mean, yeah, there are some building departments that do have, some really, really high speed, low drag kind of individuals on there who can really take this on, but not every municipality really has that. I think the other item that we're seeing right on the horizon there is envelope backstops. So in the past, where to go the prescriptive route, pick your values from the table and design to that. Or you can go the performance route if you want a little bit more glass on that building. We're saying, all right, yeah, you can look at that whole building performance, and yeah, you probably really need to, but they're only going to let you get too cheeky and give up, somewhere else that trade-off, so you can have a little bit more glass. I'm making it sound like glass is the bad guy, but that's just the easy example that you have on there, and we're already seeing that in New York and Massachusetts already having those provisions.
Yeah, that's right.
Lots to talk about in that, I'm sure. I think of what you're talking about with glue and now glass. It's like I hopefully, they've, yeah. We don't ever want to see the glass falling off the building either.
Definitely. It's happened.
I'm sure it has, right? No, please make sure it stays on. So, with all these changes and things that are happening, it's always fun to talk about what's coming up or what's the shiny new object, Will, as you were saying earlier. But what do you see as some of the trends that you're most excited about, or that everybody should be most excited about, that are happening, that are coming up in 2023 and beyond?
Gosh, well, I think what's coming up in our mind, and what we're seeing a lot of, is we've always had innovation in construction cladding systems and all that, but there seems to be a pretty significant push right now towards unitizing systems. Putting small pieces together into larger panels and then putting them on a building as one monolithic element. And that it's a great way to save labor. It's a great way to improve quality control from from a fabrication standpoint. Um, and so we're seeing a lot of movement in that area, I think, which is interesting. And these systems are being they're very creative and very innovative. Challenges are always going to be, again, as Will said earlier, it's all about where these things come together and how that works. So we've kind of moved the problem from a micro scale to a macro scale by making these larger panels, larger wall elements that then become integrated into design. So I think we'll be looking at different ways to look to detail and evaluate those things as they're constructed. The integration and marriage of MEP services with enclosure services, I think, is a huge area where we're going to continue to see a lot of collaboration and a lot of development. I think a lot of us enclosure guys are going to have to learn a lot about energy performance and mechanical systems to really stay current and stay valued. One trend in building, which I think came out of COVID, which is kind of an interesting thing, is this: we're seeing in our market a lot of conversion of office space to residential, which is really interesting and a wonderful challenge from an enclosure standpoint, because the purposes of each occupancy are so different, and the ability to kind of create and make those spaces work and function as residential space is a lot of fun, frankly, and perhaps adds a lot of value as our trend seems to be for a need for more residential and less commercial. Partially out of COVID and partially just the way we're moving as a society. And so that's been a lot of
Oh,
fun.
that's so
I hope we'll work
interesting.
on that. Yeah, I hope to do more work in that area.
Oh, that is really cool. Yes. Well, tell me what you're thinking. What's your shiny object?
Well, I'll start at the high level and zoom down in. So first off, I think Matthew was alluding to this in terms of a holistic design process. We're seeing more and more, even if we want to have not what I'd call necessarily the highest performing building, but a high performance-ish kind of building, even really need a buy-in and integration and conversations between multiple parties, and not just once. need to keep iterating this, and you can have, everyone complain a little bit in terms of rationalizing that fee and whatever, or saying I've designed this building 15 times now, but you're really zeroing in on, for instance, us hearing that dream from the architect and then coming up with different wall systems to evaluate, and then having that energy modeler plug that in to the whole building energy model to see, all right, we can tweak these microscopic bits here that we deal with in the enclosure design and analysis, but does it really make that big of a difference overall to the entire building? I think the other thing that I mentioned earlier, and I'm sure everyone's heard of now, the carbon issues. What makes the most sense, operational or what do we care about the most, operational carbon, embodied carbon, and not only that, but saying let's throw time into this too. It's not just, all right, here's the best material, but what's the most durable material, like CLT, mass timber, even timber curtain walls, really, that we're seeing more and more. Right at that initial point, wow, they're right out of the gate on that. But let's look at durability and not just look at those materials necessarily, but the system as a whole, so that they can be very durable. And those materials that aren't so much, those components that aren't so much, we can access those, remove, replace, upgrade, etc. I think the area that Matthew brought up before, so I'll try to be quick about it, is reclads, reuse, upgrades. That sit on a couple AIA committees, and we just finally got this annual billings stats that come back, the data, the index, billings index, I think is what they call it. And they're saying on average, for the first time in history, the responding firms are estimating that over half of their total design billings over the past year are from reconstruction projects. So renovations, retrofits, rehabilitations, alteration, et cetera, are coming from that existing building stock. You look at the country's largest landlord, if you will, the GSA, and already they're saying, yeah, the stock that we have right now, 70% of it is what can be considered as historic, being 50 years or older. So I think there's going to be a lot of exciting things to come out of that. Going back to tolerance, what happens when you unwrap that building? What kind of a present do you get?
Oh, yeah.
And,
yes. You're calling that a present?
Yeah, exactly. Can we
Careful
reuse
what
some
you wish
of it?
for.
Yeah. What can
this
we
will
save?
be easy. Just take that wall out.
Yeah. How much money am I going to save? And yeah, exactly.
Well, what we've always said is, the greenest building you can have is the one you use over again. Right? If you talk about carbon, you talk about on any level, adaptive reuse is a greener, more sustainable process than building new. And the more we adapt that, it folds into a lot of other things that really can advance our construction industry and make us a more sustainable society too.
Yeah.
Very, very exciting. Well, you guys, I think you've given me about 15 more topics that we can talk about. So there's no doubt we'll be following up so we can continue the conversation, because there's always great things to talk about here. But I'm very grateful for your time and your insight with all your years of experience. Thank you so very much. If anybody has any questions for you guys, what's the best way to get a hold of you? Matthew, let's start with you.
I am certainly reachable by email, and that email is mfarmer@wje.com. So pretty much first initial, last name, and company initials. Also available through our website, www.wje.com. So feel free to throw anything at me. I'm happy to help.
Fabulous. And Will?
Yeah, email would be the best for me as well.
Okay.
W Babington, so Babington down here, at studionyl.com. And yeah, happy to. Like I mentioned, spreading this information is how we make this change and make that difference. So
the best way, as always. Again, thank you for your time. We look forward to talking again soon. And if anybody has any questions for us, it's buildingenclosureonline.com. And while you're there, make sure you sign up for our free e-newsletter so you can always stay up to date on our great videos and podcasts that we're doing today, like with Matthew and Will. But most importantly, stay safe and healthy, and we can't wait to talk to you again soon. Thanks again, gentlemen.